Theorems on triangle inequality. Yan ang pag-uusapan natin ngayon dito sa ating matsayang talakayan. Kaya, stay tuned! Hello, grade 8 learners! For today's video, we will talk about theorems on triangle inequality. With the learning competency, illustrates theorems on triangle inequalities. First, exterior angle inequality theorem. Second, triangle inequality theorem. And the last one, we have the hinge theorem. In this video, we will focus on inequalities in one triangle. So we have there the exterior angle inequality theorem and the triangle inequality theorem. Now, let's talk about inequalities in one triangle. Let's start with exterior angle. The exterior angle of a triangle is the angle which forms a linear pair with an interior angle of a triangle. For example, we have triangle A, B, C with the interior angles, angle 1, angle 2, and angle 3. When we extend side AC, so we will form an exterior angle, and we call it as angle 4. So angle 4 and angle 3 forms a linear pair. Angle 4 now is an exterior angle. When there is an exterior angle, we also have remote interior angles. A remote interior angle is an interior angle that is not adjacent to the exterior angle. For example, in triangle ABC, angle 4 is the exterior angle. Which do you think are not adjacent to it? Correct! Angle 1 and angle 2 are not adjacent to angle 4. Since these angles do not have common side and do not have common vertex. Hence, angle 1 and angle 2 are called the remote interior angles with respect to angle 4. Now, let's consider the given figure to determine the exterior angles and the remote interior angles. Extending side AC, so we will form angle 4. Angle 4 now is an exterior angle. And the remote interior angles, with respect to angle 4, we have angle 1 and angle 2. Another is when we extend side BC, so you will form angle 5. Angle 5 is now an exterior angle. And the remote interior angles with respect to angle 5, so we have angle 1 and angle 3. And then, when AB is extended, then angle 6 is formed. Angle 6 is an exterior angle. Angle 2 and angle 3 are now the remote interior angles with respect to angle 6. Take note that there are two exterior angles at each vertex. For example, in triangle JOY with the interior angles 1, 2, and 3. When JY is extended at vertex Y, you will form angle 4. When OY is extended at vertex Y, you will form angle 5. Then, angle 4 and angle 5 are the exterior angles at vertex Y. When JO is extended at vertex O, so you will form angle 6. And when OY is extended at vertex O, so you will form angle 7. So, angle 6 and angle 7 are the exterior angles at vertex O. And when JY is extended at vertex J, you will form angle 8. When JO is extended at vertex J, you will form angle 9. So angle 8 and angle 9 are the exterior angles at vertex J. With these exterior angles, we will have the remote interior angles. And these are angle 1 and angle 2 are the remote interior angles of angle 4 and angle 5. And angle 2 and angle 3 are the remote interior angles with respect to angle 8 and angle 9. Also, 1 and angle 3 are the remote interior angles of angle 6 and angle 7. Now, let's proceed to exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Considering the given figure, angle 4 is the exterior angle and angle 1 and angle 2 are the remote interior angles. So we will have the measure of angle 4 is equal to the sum of the measures of angle 1 and angle 2. Now, let us solve for x in each of the following triangles. On the given triangle, 120 is the measure of the exterior angle. X and 30 are the measures of the two remote interior angles respectively. The exterior angle 120 is equal to the sum of the two remote interior angles x and 30. So we have 120 is equal to x plus 30. To solve for x, combine similar terms. So we will just simply transpose 30 to the other side of the equation. So we will come up with 120 minus 30. So 120 minus 30 is equal to 90. So therefore, the value of x is equal to 90. On the second figure, as you can see, we have tick marks. The tick marks shows congruent parts, meaning that the given triangle is an isosceles. Since one of the base angles measures x, so the other base angle will also represented by x. Now, we have the exterior angle 50 is equal to the sum of the two remote interior angles x. So we have 50 is equal to x plus x. Then combine similar terms. X plus x is equal to 2x. So 50 is now equal to 2x. To solve for x, simply divide both sides of the equation by 2. So 2 will be cancelled out and 50 divided by 2 is equal to 25. Therefore, the value of x is 25. Now, let's consider another triangle. As you can see in the figure, 120 and 95 are exterior angles. To solve for x, either of the given exterior angles can be used. For the solution that I will show you, we will use 120 as our exterior angle. And with that, we need to solve the measure of the other remote interior angles and mark it as y. Take note that y is adjacent to 95 and form a linear pair. Remember that angles in a linear pair are supplementary. So we have 95 plus y is equal to 180. To solve for y, we just simply combine 180 and 95. So 180 and 95 is equal to 85. Now, let us solve for x. The exterior angle 120 is equal to the sum of the two remote interior angles, y, which is 85, and x. So in symbol, we have 120 equals 85 plus x. And to solve for x, just simply combine 120 and 85. So, 120 minus 85 is equal to 35. So, therefore, the value of x is 35. Going back to the first example that we have, let us compare the measures of the exterior angle to the measures of the remote interior angles. So since the value of x is equal to 90, we can say that the exterior angle 120 is greater than 90. And since the other remote interior angle is 30, so we can say that 120 is greater than 30. This shows the exterior angle inequality theorem. Exterior angle inequality theorem states that an exterior angle of a triangle is greater than any of its remote interior angles. In the given figure, angle A is the exterior angle, and angle B and C are the remote interior angles. So we can say that the measure of angle A is greater than the measure of angle B, and the measure of angle A is greater than the measure of angle C. For example, in the figure, if 120 is the exterior angle and its remote interior angles are 85 and 35, so we can say that 120 is greater than 85 and 120 is greater than 35. So if we are going to have 95 as our exterior angle, 35 and 60 are the two remote interior angles. So we can say that 95 is greater than 35 and 95 is greater than 60. On the last figure that we have, since we have here isosceles triangle, this angle also measures 25. So, 50 as our exterior angle is greater than 25. Let's have another inequality theorem. So we have here triangle inequality theorem number 1, which is what we call the side angle relation. It states that if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. So let's say we have our figure, triangle A, B, C. If AC is longer than BC, then angle B is greater than angle C. For example, in triangle FIX, the angles are angle F, angle I, and angle X. And the sides are IX, FX, and FI. Angle F is the opposite angle of IX. Angle I is the opposite angle of side FX. And angle X is the opposite angle of side FI. In triangle FIX, if the measure of FX is 20 and IX is 15, so let's compare the measure of angle F and angle I. Since FX is longer than IX, we can say that angle I is greater than angle F. So opposite the longer side FX is the larger angle, angle I. Another theorem is the triangle inequality theorem number 2, which is the angle side relation. It states that if one angle of a triangle is larger than a second triangle, then the side opposite the first angle is longer than the side opposite the second angle. So let's say in our given triangle, angle A is greater than angle C. So we can now say that BC is longer than BA. For example, in triangle FIX, if the measure of angle F is equal to 80 and the measure of angle X is equal to 55, so let's compare the measures of Fi and Ix. Based on the given measurements, angle F is greater than angle X. So we can now say that Ix is longer than Fi. Because opposite the larger angle, F is the longer side Ix. For the next theorem, let us have this activity. Can you make a triangle with the given measurements? With the given measurement, we cannot make a triangle. How about these measurements? Yes, we have formed a triangle. Let us now see the condition on what is the required measurement of the sides for us to form a triangle. On the first figure, when we get the sum of the first two sides and compare it to the third side, so we have 13 plus 4 is 17, which is greater than 6, so that is true. 13 plus 6 is equal to 19, which is greater than 4, that is true. But when we get 6 plus 4 is greater than 13, so that is false. So let us try on the second figure. If we get the sum of 12 and 5, it is greater than 9, so that's correct. When we get the sum of 12 and 9, which is greater than 5, and that is also true. And when we get the sum of 9 and 5 is still greater than 12. So what does this mean? This is what we call the triangle inequality theorem number 3. It states that the sum of the length of any two sides of a triangle is greater than the length of the third side. So on the figure, the first two sides, A plus B, is always greater than C. And when we get A plus C, that is greater than the third side, B. When we get B plus C, that is greater than the third side, A. For example, let us tell whether the given length can be measured of the side of a triangle. So for number 1, we have 2 centimeters, 4 centimeters, and 6 centimeters. So let's get the sum of the first two sides. So 2 plus 6 is greater than 4. 2 plus 6 is 8, and 8 is greater than 4. Then we have 4 plus 6 is 10, which is greater than 2. And 2 plus 4 is equal to 6, greater than 6. Is that correct? So let us see. For the first one, that is true. Then we have true, and this is false. So therefore, we can say that the measurements 2, 4, and 6 cannot form a triangle. For example, number 2, if we have 4, 6, and 8, 4 plus 6 is 10, greater than 8. That's correct. 6 plus 8, greater than 4, is 14, greater than 4. That's correct. 4 plus 8 is 12, greater than 4. That's correct. So all statements are true. So therefore, we can say that these measurements can form a triangle. And for number 3, if we have 6 centimeters, all sides, we have 6 plus 6 is greater than 6. So it is always 12 is greater than 6. So the statement is true. So we can say that this will form a triangle. And for number 4, we have 19 plus 13 greater than 4. Correct? 13 plus 4 is 17 greater than 19. That's not correct. But we have 19 plus 4 is greater than 13. That's correct. So this is true, this is false, and this is true. Meaning that these measurements cannot form a triangle. And now it's your turn. Get your paper and pen and do this activity. And that's for today, guys. Do not forget to like, subscribe, and share. Again, this is Teacher Dali na nagsasabing, practice makes perfect. Thanks for watching!